Friends, today we look at the 9th lecture in module 3, where we are going to focus on industrial hygiene control. This is lecture in module 3, where our focus on accident modeling, risk assessment and management. We already saw that how fire and explosion can be averted, prevented, how they can be modeled effectively, so that fire and explosion can be avoided to some extent, or the serious damages which could arise from an explosion, maybe detonation, maybe deflagration, can be controlled to some extent, so that the economic loss does not matter much in case of explosions. Extending the study, we will focus on industrial hygiene control. There are two major techniques by which you can control hygiene in the industry. The two major techniques are one, environmental control, second could be the personal protection. So, when you talk about environmental control, the main aim in environmental control is to reduce the concentration of the exposed toxicants in the workplace. So, the main objective is to reduce the concentration of exposed toxicants. In the workplace. How to achieve this? One should provide a good local ventilation. One should also see how possibly toxicants can be diluted in sense by admitting fresh air and therefore dilute the concentration of the toxicant or the mixture. So, one can also provide good and very large openings which serve two purposes. In case of emergency, they will be very useful for speedy evacuation. Two, it becomes also easy and convenient to have large admittance of fresh air. So, this will be useful in diluting the chemical concentration. One can also alternatively use what is called wet methods. By making the surface wet, you can always reduce the contamination caused by dust. more importantly, a very good and periodically scheduled housekeeping is the key for an improved hygiene in the industry, and this helps to control the toxicant concentration and the dust contamination to a very larger extent in the workplaces. The second idea could be personal protection. The foremost interest in personal protection is a very interesting and a strong capacity building towards safety programs, let us say safety training programs. It is also interesting that periodic assessment of training, need to be conducted to really assess the understanding of the workers, the understanding of safety practices. Sometimes people used to conduct fire drill, which is essentially a mock drill, but this is going to give a one to hand experience in case of any fire, etc. So, periodic assessment of training is also important. In addition to that, one can also use certain safety measures by displaying posters or let us say tips about a good safety program. I have seen a very interesting poster which I would like to share with you in one of the workplaces. People say HSE, Health, Safety, Environmental Management, actually comes in cans. Okay, they draw a picture of a can, say it comes in cans. You can, I can, and therefore we can. So, this kind of posters will help people to develop self confidence on the workspace safety, and you should also indicate rules on let us say do's and don'ts, very specific in case of workplaces. People should also advocate use of personal protection equipments, PPE, like helmets or what they call in industrial language as hard hats, safety glasses, welding goggles, chemical splash goggles, splash suit, boots, earplugs, etc. So, one should always advocate very strongly. In fact, the industry should supply at their cost all these personal protection equipments to people on board, so that one can always can improve the industrial hygiene to some extent. Once we talk about accident modeling and we learn how accidents are occurring and how they actually spread, because we have seen dispersion models, we have understood the causes because of overpressure and negative pressure, we have already seen what is a blast wave and a shock wave, the difference between detonation and deflagration which occurs essentially from the dust and from the chemical pollution. So, let us now see what are those elements which are important to control process accidents. We all agree and know and now at least realize that chemical plants are an important source of accidents. I mean, there is no doubt on this, because the process is highly hazardous and eventually a situation may change and this can become a disaster. Okay. For example, oil spill, fire, explosion, toxic release, of chemicals, reactor runaway, fugitive emissions, etc., which are unavoidable and they are really accidental. So, these are possible sources of hazards. If not managed properly, they may result in initially incidents and then they can propagate to become, or they can grow to become accidents. We already know the terminology difference between incident, accident, etc., hazard and risk, etc. In addition to this, the second interesting source of process accidents come from mechanical hazards. These are because of chemical plants or chemical releases, stock of inventory of chemical. Mechanical hazards can also be very interestingly a problem in process accidents. This includes improper maintenance, irresponsible shift handovers, no reporting of near miss, events, improper because of tripping, because of falling or moving equipment, so they all become main contributors for oil spills, fire and explosion in chemical industries. Let us quickly summarize them interestingly. Please pay attention to the comparative chart, or in fact a table which is shown on the screen now. Let us look at three major type of accidents: fire, explosion and toxic or chemical release. Let us divide this into three categories of chances of occurrence, that is probability of occurrence, fatality chances, that is the consequences are very highly damaging, or we can also see what is the probability of financial loss. As I said, risk assessment and management should ultimately encounter or encompass also the financial aspect or economic perspective. So, if you look at fire as an accident type, the probability of occurrence and if it occurs, the fatality chances are very high, whereas the financial loss is intermediate. Whereas look at the explosion, the probability of occurrence and fatality are intermediate, but if they occur by any chance, the financial loss is phenomenally high. Same with a toxic release, but one good thing about the toxic release is generally because of effective design and good dilution of released chemical because of addition of fresh air in dispersion models, the chances of occurrence and fatality result from those occurrences are relatively low compared to these two type of accidents, but however, the financial loss involved is very high. So, one looks actually a combination of this. So, accident type may be fire, since because the financial loss is intermediate, we need not be happy. On the other hand, the toxic release, the chance of occurrence and fatality are very low, we need not be happy. All the three are important to be handled in risk assessment and management very effectively. Having said this, now let us talk about some discussions on toxic release models, because we discussed about the fire and explosion models in detail. We have understood how they can be modeled and what are the serious consequences, how you can easily find the workplace overexposure limits for a given mixture. If such chemicals or toxicants are released in environment, how do we mathematically model them, and actually how do we know what is the indirect risk caused by these kind of released chemicals to the society and to the individual. To know that, let us start with understanding different class of hazardous materials. Now, hazardous materials come into different variety, which are very commonly used in process industries like oil and gas downstream sector. Let us say flammable material. In our case, the hydrocarbons are highly flammable. Combustible material. In our case, the gas and oil produced are highly combustible in nature. Toxic chemicals. In our case, whatever chemicals we add for recovering the commercial oil and gas from the crude oil processing is all toxic. We also deal with what we call unstable materials. That is why interestingly we have understood the dispersion models in TNT equivalence. If you remember, in the previous lectures we discussed about this, TNT is considered to be one of the most unstable system which can be easily mixed up, okay? And highly reactive chemicals. Highly reactive chemicals. Now, they all fall under a category of hazardous materials. We deal with almost all of them. Once you have a presence of hazardous material, then accident has got 3 stages, which we already discussed earlier, but let us apply this towards safety practices. Okay. So, there are 3 stages: initiating events, which can arise from equipment malfunction, containment failures, which can also arise from thermal runaway, human error in operations, which arise because of oversighting, maintenance difficulties or maintenance errors. These all can be interestingly powerful initiating events which can result in a very catastrophic accident. Once the initiating events are existing, then there can be something called intermediate events, which are also otherwise called as propagating events. Now, these events are responsible to propagate the initiating event to result in a catastrophic disaster. What would be the parameters which would be adding significant contribution to propagate an initiating event? The parameters could be temperature, pressure, flow rate, and their deviations. They all could be interesting parameters. In addition to that, let us say presence of toxic material in abundance, presence of ignition source or explosion possibilities. Are all examples for events which can propagate the initiating event and leading it to further disaster. Of course, we all agree and we know, because you may be asking a question here. So, we in offshore industry or in process industry, do we have any control mechanisms which are designed as a part of the system which can control either the initiating or the propagating events? The answers are yes. There are intermediate mitigating events. Let us quickly see what are they. We can say safety system responses. Some example can be given here: relief valves, let us say PRV, pressure relief valves, grounding, and backup utilities. We have power backup utilities in case of uninterrupted power supply, in case of external DG sets, etc. All these can be identified as safety system responses. We also have mitigating system responses. So, mitigating system responses are also present in a given system. For example, we have lot of emergency vents given in a containers to escape out the extra fluid or the chemical, toxic chemical which is packed in the vessel. We also have something called blowout valves which open in case of emergency. We also of course have containment dikes which you must have seen in case of oil storage plants. We also have flares and sprinklers, etc., as mitigating system responses. In addition, we also have contingency operations. Friends, it is important when you talk about risk management and assessment or industrial safety practices, you have to use actually a appropriate terminology, that is very important. Okay. You can list all of them in one shot and say these are my safety devices, but they are actually grouped in different functionalities. So, one should pick up these terminologies properly, and when you speak about them you should always use these kind of phrases. Okay, that is important. That is why I am making you to align your thinking in this form. It is not that we do not know all of them. We have been in industry practice, we know what we mean by grounding, what we mean by backup utilities, and what we mean by vents and blowout valves, we know them. But the question is how to group them, because they are all mitigating events. Why I say intermediate? Because all of them or most of them will work only when initiating event occurs. It means a blowout valve will not open until the pressure exceeds a threshold value. Pressure exceedance of threshold value itself is what is called as an initiating event. Therefore, most of these responses, maybe the safety system response, the mitigating responses, will be active only when initiating event is started. That is why we put them in intermediate mitigating events. So, as continuing here, contingency operations also we have, like alarms, we also have emergency procedures, which should be followed in case of any unhappening etc. In addition, we also have personal safety equipments which are also useful in intermediate mitigating events. We also have evacuation procedures, we also have identified assembly point in case of emergency. In every plant it is must, and you would have seen this. Security alerts, maybe sirens etc., all come under mitigating events which are intermediate in a process industry. So, once we have an initiating event, we have the propagating events. Even though mitigating events are present, ultimately it may result in an incident or it may lead to an accident. So, occurrence of accident is unavoidable because there are many uncertain parameters which can lead to occurrence of accidents, but what we are interested is to reduce, minimize the consequences of accidents. That is very, very important. Therefore, a good safety program for industrial hygiene will focus on reducing the consequences of accidents. A best safety program will talk about even reducing the probability of occurrence of an accident itself. In addition to this. So, when both are addressed, we can call that program as the best program. Mostly this is addressed in all safety programs in industry. So, we call them as good safety program, and we need not have to tell about a bad safety program, we all know that. Now, the question comes, accident or occurrence of accident are actually unavoidable because they happen because of very high uncertain parameters. We have already seen the presence of initiating events and the presence of propagating events will lead towards accidents which are all present, even though we have intermediate mitigating events. However, these events put together can align to form a mistake and they can result in incident which can be catastrophic and can be called as an accident. Therefore, what would be those steps involved in risk analysis for a process accident? So, let us say steps involved in risk analysis of process accident. First step should be, one should be able to predict the accident occurrence. To do that, one should intelligently identify all of the initiating events. Okay. One should also be able to assess the damage potential associated with each type of accident. As I said, we already have something called risk acceptability. Therefore, one need not have to focus on all type of accidents which may not result in serious destruction or damage to the system, especially in economic perspective. So, one should be able to actually assess intelligently the damage potential which can be caused by these occurrence of accidents. Once you do this, ensure the system safety during operations is what we call operational culture in industrial safety. Do not violate any safety norms when you are operating equipments, and do not neglect any serious alarms raised by the equipment or machinery when it is under operation. So, ensure system safety during operations. Now, with all that, one can always say there can be accidents occurring, we need to assess them. You can do it by two ways, as we all know. One can do qualitative way, which we call again QRA, qualitative risk analysis, which is used to predict the undesired situation. Please understand, this is only prediction, it is not a post analysis of accident. So, predict undesired situation which may arise in a process system. This identifies potential causes of chemical, mechanical hazards. Which result from the process industry. Some of them are hazard studies, probabilistic hazard analysis, failure mode effect analysis, failure mode effect and criticality analysis, etc. These are all qualitative. However, you will agree, except for ASAP, FMEA, PHA and FMECA, etc., to some extent also quantify the hazards or quantify the risk in terms of, let us say, risk priority number. We have already seen them in detail. You can also do it quantitatively, which is also called fortunately as QRA. This method is actually useful to evaluate the likelihood of occurrence of accidents. It evaluates the likelihood of occurrence This approach will be useful in determining the cause and consequence of potential hazards. So, this is useful to determine the cause and consequence of potential hazards present in a process industry. After identifying the specific cause and consequences, then it is useful to analyze the control mechanisms, that are in place then it recommends any change in the design or process line layout, so that the consequences can be reduced and of course, the likelihood is also reduced. Therefore, risk is reduced. So, obviously, these methods use probabilistic tools to estimate them. Okay. They also do fault tree analysis, event tree analysis, etc., to conduct causes and consequences of an accident. Ultimately, once you do an analysis and do risk modeling and assessment, one need to also know how to review my safety program. So, what is safety review? There are two types of safety review which are generally conducted in offshore industries. One is what we call informal safety review, the other one is what we call formal safety review. Informal safety review is generally applicable to the process where small changes are made in the existing layout. So, informal safety review is applicable to process where only small changes are made in the process layout. Alternatively, this can be done in a more formal way when there are major changes, but generally small change problems generally will be addressed with bench scale labs. So, the results will be compared, results of the analysis of the safety review will be compared with some benchmark values to declare them whether it is safe or unsafe. On the other hand, if you have major changes, if there are major changes both in the design and process layout, then one need to do formal safety review. Formal safety review is generally conducted by a team of experts who will identify the deviations, the causes and consequences, and they prepare a detailed inspection report for the process plan. So, they can also do it by preparing what is called hazard checklist. So, people do process hazard checklist. They are nothing but list of all possible hazards that a reviewer need to be considered while formal safety program, while formal safety review is carried out. Okay. These checklists contain probable consequences, they contain possible hazards and probable consequences of each hazard. So, it is a set of probable hazards that may arise, and hence enlisted hazards may not apply to all cases in the present scenario. Nevertheless, checklist remains the areas of concern to the reviewers and stimulates them to revisit the recommendations and report summary, so that any major accident in the future can be avoided even when the risk is highly remote. Secondly, one can also conduct what is called hazard surveys. This is actually a technique which ranks the hazard quantitatively. So, this is useful to rank the hazards quantitatively. This procedure is well laid in Indian Code 1656 2000, which gives a very detailed procedure about how an hazard survey should be conducted. It is very simple if the method involves only the survey inventory of hazardous materials. For example, for chemical release models, one need to conduct hazard survey for chemical inventory. Okay. This is useful for dose, chemical exposure index, to estimate the dose chemical exposure index, which we call as CEI, which is one of the interesting model which is useful for toxic release of chemicals. Now, chemical exposure index is one of the most powerful method to study the toxic release. So, most popular method to study the consequences that arise because of toxic release. This also includes the dispersion modeling, which we already studied in environmental pollution in case of module 1. So, this is a very interesting tool which is commonly used and acceptable internationally to estimate the consequences which arise from toxic release, as stated by Henselwood and Phillips in 2006. So, friends, in the next lecture we will have detailed time spent on how to estimate the chemical exposure index for a toxic release. We will do a couple of numerical examples to understand. We will also take an industrial example how to estimate CEI for a given problem. So, couple of lectures from next class onwards will be dedicated to how to do a chemical exposure index for different kinds of toxic release scenarios which can happen in oil gas industries. Thank you very much.